Hello, I'm Tony Ko, the host of TalkIT Global. In the past, humans handled data manually. We scanned spreadsheets and reports for numbers. Back then, a CPU was all we needed. But in the AI agent era, AI reads, organizes, and connects data at a massive scale. It's the difference between one person flipping through a file and hundreds of people searching at once. At NVIDIA GTC 2026, Jensen Huang introduced cuDF, a GPU library for structured data. Let's watch.
Now, we're going to have AI use structured data, and we better accelerate the living daylights out of it. It used to be okay, and we would accelerate the structured data so that we could do more, we could do it more cheaply, we could do it more frequently per day, and keep the company running at a much more synchronized way. However, in the future, what's going to happen is these data structures are going to be used by AI, and AI is going to be much, much faster than us. Future agents are going to use structured databases as well. We've been working with Google Cloud for a very long time. We accelerate Google's Vertex AI. We now accelerate BigQuery, really important framework and really important platform. And this is an example of our work together with Snapchat, where we reduced their cost of computing by nearly 80%. When you accelerate data processing, when you accelerate computing, you get the benefit of speed, you get the benefit of scale, but most importantly, you also get the benefit of cost. And so all of those come together as one.
As we saw, Snapchat cut computing costs by 80% using cuDF. Now, I'll explain the technical details in simple terms based on their official documentation.
This is the new bottleneck. It's not just about having enough computing power anymore. The real challenge is feeding the machine. And that brings us to a company that knows this problem better than almost anyone, Snap.
At Snap, A/B testing isn't just some tool they use. It is the very heart, the engine behind every single product decision they make. Any new feature, any little tweak to an algorithm, it all has to go through their experimentation platform.
And the scale we're talking about here is, well, it's just staggering. They process 10 petabytes of data every single day. Just try to wrap your head around that for a second.
So how in the world do you handle that fire hose of data? Well, you use a massive fleet of about 100,000 computers. The coordination alone is just mind-boggling.
And here's the real kicker. All of that work, all that data has to be processed, and the results have to be 100% accurate and on the table by 11 a.m. sharp. No excuses. Why? Because thousands of engineering decisions are completely blocked until those results come in. Failure is not an option.
Okay, so facing this insane challenge, they started looking for a solution. And they found a glimmer of hope with NVIDIA's Rapids accelerator for Apache Spark. Now, the big promise here was huge, massive speedups with zero code changes. For any engineer, that is the holy grail.
And the first tests, they were just astonishing. I mean, look at this. On one of their critical jobs, the total compute time plummeted from 400 hours on CPUs all the way down to just 28 hours on GPUs. That's an incredible speedup.
But what's really interesting is how it got so much faster. See, in big data, there's this nasty thing called a spill. It's when you run out of fast memory and have to write to the slow disk. It's a total performance killer. And with GPUs, look at that. 58 terabytes of spills, gone. Just vanished. The technology was clearly a massive win.
So, the case for GPUs was a slam dunk. They were faster, they were more efficient. Problem solved, right? Well, not quite. In fact, their amazing solution created an even bigger, more terrifying problem when they did the math to scale it up.
Even with all those incredible efficiency gains, they calculated they would still need, get this, 20,000 GPUs, all running at the exact same time during their peak window. 20,000!
And here's the thing, that many on-demand GPUs just didn't exist. Not for them to rent in the cloud anyway. They had hit a brick wall. Their perfect technical solution was actually impossible to implement in the real world. Dead in the water.
So what do? You can't buy your way out of the problem. The team had to get really, really creative. They started asking, okay, where can we find thousands of GPUs? And they started looking inside Snap itself. And they found them in a place you might not expect.
It turns out Snap already had this massive fleet of GPUs running their ML inference platform.
This is the stuff that does all the real-time AI magic in the app, ranking ads, recommending content for almost 1 billion users. But the key thing is how and when those GPUs get used.
And this is where it gets brilliant. User traffic, it follows the sun. So when Snap's biggest markets, the Americas, go to sleep, the usage on that giant GPU platform just plummets. This created a predictable little window between 2 and 5 a.m. Pacific time, where thousands of powerful GPUs were just sitting there, paid for, but doing nothing. And that was their light bulb moment.
So their whole mission flipped on its head. It was no longer about buying new GPUs. It was about building a whole new platform to opportunistically borrow the idle ones. They re-architected their data pipelines to run in that crazy 2 to 5 a.m. window. And they built the system to be smart. Use the GPUs if they're free. But if not, no big deal. Just fall back to CPUs. The GPU speed became a bonus, not a requirement.
All right, so after all that work, this was a huge, multi-quarter effort. What was the payoff? Did this incredibly creative solution actually work? Well, the results were, frankly, staggering. A 90% net cost savings. 90. By using resources they already owned, instead of provisioning tens of thousands of new ones, they slashed the cost of their entire data platform. That's not just an improvement, that is a total game changer. And here's what their new super lean cost structure looks like. You can see that huge blue slice? That's all the work getting done by those repurposed GPUs. The other little slivers are just their fallbacks in storage. It's an incredibly efficient model.
And the best part? They did all this without sacrificing stability. The platform is rock solid, with success rates over 96% for those critical daily jobs. And on top of that, they dramatically reduced their CPU and memory usage. It's just a win-win-win across the board.
Snap's story is such a powerful lesson for this new era of AI. It shows that the most innovative solution isn't always about buying more, faster hardware. It's about thinking differently about the resources you already have. And it leaves all of us with a really critical question. What powerful assets are you already paying for, just sitting there, waiting to be unlocked?
Lastly, your likes and subscriptions greatly empower us to continue creating content. Thank you for your support.